Hi students, welcome to chemistry online classes. Today I am discussing about thermodynamics. Thermo mean heat. Dynamics mean change. Or it is also known as a flow. It means heat flow. Thermodynamics explain about the heat change or heat flow from one form to another form, otherwise one state to another state. That is thermodynamics. This thermodynamics explains about the energy change involved in a system which involving the large number of molecules rather than the fewer molecules. So this thermodynamic explain about a system which having the large number of molecules, that is called a macroscopic system. It explain about the energy change in a macroscopic system involving large number of molecules rather than microscopic system with few molecules. Keep in mind, this thermodynamic explain about the macroscopic system which having the large number of molecules, but not with the microscopic system having the fewer molecules. Keep in mind, in a classroom, for example, 100 number of students are there. That is large number. In a classroom, 5 members are there. This is a 100 member, this is a 5 member. Then, in this, if you explain the pass percentage or the first rank, second rank, it is somewhat meaningful. In this, the pass percentage or the first, second rank is not the meaningful. It means meaningless. Therefore, the thermodynamic explain about the macroscopic system which having the large number of molecules. Next, what are the object? Mean it's concerned about the things, objectives, the energy change involved. It means how to determine the energy change involved in a chemical reaction or process. It will occur or not. Simply it is called feasibility of reaction. It means the thermodynamics explain. First I will write here one word. Thermodynamics explains one, feasibility means possibility of the chemical reaction, because we are discussing about the chemical change. In physics, that is generally it's called process. That's why the feasibility of chemical reaction or process. The energy change involved in a chemical reaction, how we will determine or the reaction will process or not. It means the reaction occur or not. Feasibility means the reaction will occur or not, will explain the thermodynamics. Next, what drives a chemical reaction or process? Meaning, what drives mean what is the force is required to run a process or chemical reaction, how it is move. For example, when the bike start or a car start, we are switch on the key and then the petrol or diesel burn, then it will be move. So that is called the driving force. It means some energy involved in the reaction, that chemical energy converted into mechanical energy. So here also to process a reaction, what is the driving force, what is the energy, what is something is required to proceed. Then third one, that also we can determine by thermodynamics. Next one, to what extent do the chemical reaction or process, at what, it means when a reaction occurs, that reaction, what extent it will be, it may be 50% or 100% or 90% will occur. So to what extent do a chemical reaction is carried out. The fourth one, the thermodynamic will explain only the system which is in equilibrium. So it explains only the system which is in equilibrium. So this is the objectives. Otherwise, the system which is moved from one equilibrium state to another equilibrium state, further this thermodynamic will explain. This also considered in the limitation also. Okay. So keep in mind thermodynamic. By using this thermodynamic, we will explain these possibilities. It means these are the points. One is feasibility of a chemical reaction or process. Second one is what drives a chemical reaction or process. To what extent do the chemical reaction is carried out. Then it is explained for only the system which is in equilibrium. Okay. Then we will discuss about the what are the limitations. Now, limitation. Already I told you that the thermodynamic explains about the system which is macroscopic. The system, otherwise you can write limitation. Thermodynamic explains, thermodynamic explains the system which is macroscopic with large number of or large number of molecules. Second one, it not concern or does not concern, anyone simply write not concern about how and what rate of energy transformation is carried out. Simply it is to understand purpose. It do not explain the rate of reaction. ROR means it do not explain the rate of reaction. This you will study in the second year chemical kinetics chapter. And do not explain the mechanism. Its total line meaning is do not explain the rate of reaction and do not explain the mechanism. How this reaction is carried out, you may be knowing the organic chemistry, one step-by-step process will be there. So, how mean mechanism, what rate, it means this reaction is carried out in the 1 second or 1 minute or 1 hour or 1 week. So, in given time, it is completing or not, or total time taken for this reaction or process is also not explain this thermodynamics. And already I told you that in the objective it explain about the system which is in equilibrium. The system which is in equilibrium. For that only it is explained, otherwise no. So these are the demerits or limitation of thermodynamics. Objectives are feasibility of reaction, what drive a chemical reaction or process, what extent do the chemical reaction proceed. So that are the objectives, mean that we will study from the thermodynamics. These we will not study. It means microscopic object it not explain, and do not explain the rate also, mechanism also, and the system which is in equilibrium only it explain, otherwise not. So the system which is in equilibrium, for that only it is applicable. Okay, it explains, thermodynamics explain the system which is in macroscopic and do not explain the rate. So these are the limitations. Now thermodynamic terms. In this thermodynamic terms, we have one is universe. Universe is combination of system plus surroundings. System plus surrounding. So what is a system? What is a surrounding? Now we will discuss. Universe is a combination of system plus surrounding. Now consider this is total is universe, like our universe. Now in this beaker we have water molecule. Consider this is a beaker, this is water, H2O, this is water. This H2O is, I want to consider system. What is a system? Anything, otherwise in universe it is a part. System is a part. System is a part of universe in which observations made. Otherwise, another definition, it is a part of universe under thermodynamic study. It is a part of universe under thermodynamic study, is called system. This whole is universe. This whole circle is universe. In this circle, what is included? That is system and surrounding. So water molecule is, now I want to consider system, and this part is, it means other than this beaker. Other than this beaker means this empty part. This is called surrounding. Surroundings. Surroundings is include everything in universe. It includes everything in universe other than or except anyone other than system. That is called surrounding. Simply it is a, in bracket you can note down, neighborhood of system. It is a neighborhood of system. Now in between the system and surrounding, this is the surrounding part. This is a system. In between these two, what is there here? One boundary is there. So this is called boundary. Boundary is what is that? Now it is real. Beaker wall is real. Now we can consider this is a system. The pen, now marker is a system. The remaining part is the universe. Now this ink is I am not considering the system. Total pen I want to consider system. Then here in between the system and this is a system I am surrounding. What is the wall or what is the line is there? There is no line. This total is system in up to here there is a surrounding or up to here surrounding or up to here surrounding. There is some imaginary line. If you consider the one place in our country, for example, now we are in the Dharwad. So now the Dharwad is one of the system. If you consider the surrounding of this Dharwad is they are having a imaginary line. So that is called boundary. For this Dharwad also we have one boundary. That is just imaginary line. Otherwise we can't draw like this circle around this Dharwad. So imaginary line or real. This is a zone or line or wall. So this is called a real boundary is a real or imaginary. You read complete word imaginary zone or line or wall, anyone. A real or imaginary zone or line or wall which separates the system and the surrounding. Which separate the system and surrounding. That line or that wall is called boundary. Now this boundary is made us or we can control or we can keep track how this transformation of matter or energy change involved from system to surrounding or surrounding to system. Now this water, it may get some extra molecule or it may gain some energy from the surrounding or it may lose energy from system to surrounding. This transformation we can control or we can keep track by this boundary. We can make into that our wish how to control, how to keep track. Based on that we can prepare this wall also. So based on this wall only this energy transformation will occur. So this boundary is maybe, already I told you this boundary having some types. I will write here. This boundary may be real or imaginary, one type. Second type, this boundary may be, what do you call, rigid or flexible. Now consider this board. Board is rigid, not flexible. Now consider this skin, this wall is which one? Flexible. If you press like this, it is moving inside. It meaning it is flexible. I can come to original position. So this is flexible boundary. Inside the blood vessel or blood is considered system. In this is what you call boundary. So this skin is flexible. Now wall is there. For any house that wall is rigid, not flexible. Once you press mean not easily compressible. It means that is rigid. This is real or imaginary mean what is that? This wall is appearing mean this is real. Something it is. We are considering in the diagram. What do you call India map? That is what is that? Imaginary line. So these are rigid also, flexible also. Another one is, third type is diathermic or adiabatic. Boundary may be real boundary or imaginary or rigid or flexible. Third one diathermic or adiabatic. Here Q not is not constant. It means heat. Q mean here heat. Here Q is heat. Heat is constant. Now you can take the thermo flask or the maybe some Milton water bottle or some in that or hot box. We can keep the hotness or coolness up to maximum 24 hours. If you keep hot water, then hot water up to 24 hours it may be hot, or cool mean 24 hours cool maybe. After that slightly its temperature or that hotness or coolness will be changed. So that is what you call heat is constant. In ideally there is no 100% adiabatic system not there here, but the 24 hours only we have to consider this adiabatic process. So heat is constant. In hot box, if you keep the hot food, that may be maximum up to certain hours only, but not up to 2-3 days. Okay, so that is heat is constant. Here diathermy meaning what is that? If you take the water bottle, closed water bottle, and keep the water bottle outside in the sunlight, after one day if you observe that somewhat volume will be decreased, water volume will be reduced. It means otherwise it may keep outside mean simply it gain the energy from the atmosphere and the cold water is converted to hot water. Otherwise if you keep the hot water, then it may be converted to cool water because the energy change involved. That is diathermic boundary. This is adiabatic. Another one is 4-to-1 type. It may be all are different word we are using. Another is permeable and this is non-permeable boundary. Permeable. Another is non-permeable. You can write another same. Permeable mean what is that? It allows. For example, our skin, when you wash with the water, some water molecule enter inside, then only your face is look somewhat glow. It means water molecule little bit enter. It means it look the fresh. If you put the flower in the water, it will be revived. It means the layer is permeable. Some are non-permeable. Now we are in the house. When rain comes, the water is not enter, mean it is not permeable. So like this boundary are different types. So you have to remember these are for competitive exam purpose. Anyway, your exams are already completed, therefore I mean you are pass out. Then system and surrounding are example. These are important for PU purpose. And one more thing, keep in mind, whatever the change involved in the system. Now I am in the one room consider. If you on the AC, then this room will be cool. It is cooled out mean the whatever the change happened outside, then not affected. Inside the change happened, that will not affect to the outside. Outside mean what is that? That is the surrounding. So when I switch on the AC, then this room will be cooled down. This is cooled down mean outside, it means atmosphere surrounding of this room will be hot or cool. No, there is no any change because of the surrounding is very large. So whatever the temperature change or anything change in the system, that will not affect to the surrounding, but it may be anything affect what is the change is happen in the surrounding, it may be affected to the system because system is somewhat smaller and surrounding is very large. That's why it includes everything in universe other than the system. Other than system remaining everything, what is that? Surrounding. That's why the system will not affected whatever the change involved in the surrounding is not affected whatever the change involved in the system. So that is very important, because if you increase the heat, inside, for example, your all lights are on, or it may be stove is burning, it means gas, when you switch on then it is burning, mean due to this the temperature is not increased outside, because that is very small change. So these are the very important thing, because we are not dealing about the surrounding in this chapter, we are totally dealing about the system only. This system is equilibrium with the surrounding. So it can lose matter or energy to the surrounding, or it may gain from the surrounding also. So these two are in equilibrium, but system is only affected but not the surrounding. Now, types of system. We can classify the system because already I told you that in this chapter we are discussing about only system but not surrounding. So this system can be classified. We can classify the system based on movement or transformation of matter and energy through boundary. So based on this, we can classify into three types. One is open system. Later I will write the what is the next one. The first one is open system. Now take the one beaker. This is open. In this water molecule or anything, some reactant consider. This one, it may out or something may be in. Energy may be loss or energy may be gain. So this is energy, this is matter. This is energy. So between this is system, this is boundary, this total part is surrounding. In between the system and surrounding, exchange of matter and energy. Exchange of matter and energy takes place or possible. Because this is open. So this, if you keep the beaker, water beaker, it means water contained beaker, then this water molecule after some time it may escape because it gained some heat and this is vaporized. Or if you cool down, then some water molecule dust something may be enter into this beaker. So matter can exchange, energy also exchange. Therefore, I want to write delta mean change, M mean mass. Mass is not constant. If constant means there is no exchange, that is equal to 0. Delta mean change, energy also not constant. Second one is closed system. In closed system, this is considered closed, there is no gap. So now something matter is present in this, any reactant mixture consider or maybe water only consider, there is no problem. So energy can exchange. Now water bottle consider, closed with a cap. Then that water, hot water, after some time it may become to cool, or cool water it may turn to hot due to energy transformation. So energy can exchange, but matter cannot be exchanged because it's totally closed. Energy can exchange. Here both are possible, but here energy can exchange but not matter. So no exchange of matter, but energy can be exchanged. Therefore, delta M is constant. It means mass cannot be changed because mass is not enter. It means matter is not enter or out. Here, delta E is not constant. The third one is very, very important, that is called adiabatic system. Already I told you the adiabatic boundary. Adiabatic boundary means what is that? Hot box consider. So in this already we have one closed system. Around this another layer will be there. In between this layer some matter will be present. Now we can consider the Milton water bottle hot. It can keep 24 hours hot and cool also. When you add hot water, for them this is hot water already content considered. So this hot water, after some time, it lose the heat to the surrounding. Here, which is the surrounding? In between these two layers, we have one matter. So this matter gain the energy again giving to this one only. That's why this hotness, once it lost, again it gain. Therefore, this hotness will be remain up to maximum time. That is maximum 24 hours only. 100% is there is no insulated. This is called insulated object. This is insulated. The insulated object do not allow the heat in and out. Therefore, totally this is called heat is constant. Heat is constant means this is called adiabatic. Keep in mind this is very important. Heat constant means that is called adiabatic system. So this is called thermos flask. Example, thermos flask. This is generally we will keep tea or milk, hot tea or milk for 1 hour or 2 hour purpose, or maximum it may be 1 day. So our hot boxes, these are the examples. Okay. So now we have to remember how many types are there. One is open system, another is closed system, another is adiabatic system.